Hi everyone, in today's lesson we're going to talk about how to complete the square when a is equal to 1. Now completing the square is just another way to find the roots of a quadratic equation. So before I can begin the process, I need to talk to you about what a perfect square is. So just recall that a perfect square is a number or an expression that is the result of two of the same numbers or things. So we'll say two of the same things being multiplied together. Okay, so for example, 4 is a perfect square, 25 is a perfect square, 36. They're all perfect squares because they were the result of two of the same things being multiplied together. And we've also talked about perfect squares that are letters. So we could have x squared is a perfect square, x to the 10th, x to the 12th, right? X squared because why? It's the result of x times x. X to the 10th because it's x to the 5th times x to the 5th. X to the 6th times x to the 6th, right? For x to the 12th. So that's all we've learned so far about perfect squares. But we can actually have perfect square trinomials. A perfect square trinomial is a trinomial. That is the result of two of the same binomials being multiplied together. So remember, a binomial has two terms, and these two terms I am going to multiply together. So x times x times 4, another 4x, and then 16. So if I combine like terms, I'll just get x squared plus 8x plus 16. So this is my perfect square trinomial. So what would the perfect square trinomial be if these were the two binomials being multiplied together? Well, we'll double distribute again, and we'll have x times x is x squared, x times negative 3, another negative 3x, and negative 3 times negative 3 is a positive 9. Again, combining like terms, we have another perfect square trinomial. All right, now we're going to try to make a connection about what all perfect squares have in common. All perfect square trinomials have something in common, such that it's a trinomial whose c value is half of the b value squared. So I know that sounds weird, but let's just look at these two perfect square trinomials that we just made. Remember it goes A, B, C, right? So this C value of 16 is found by taking half of the B value, so half of 8 divided by 2 squared. So 4 squared is 16. That works. Now let's look at this one. This C value is half of B, so half of negative 6 squared. So what's that? Negative 3 squared, which is 9. Perfect. So what I want you to do now is I want you to look at these three trinomials, and I want you to determine if they are perfect square trinomials based off of this new fact that we know. Is the C value half of B squared? Well, let's see. Half of B, so B is negative 2, so negative 2 divided by 2 squared. Well, negative 2 divided by 2 is negative 1. Negative 1 squared is 1. That's the C value, so yes. And let's look at the second example. Is the C value half of B? Half of 10 squared. So half of 10 is 5. 5 squared is 25. Is that the C value? Yes. Okay, last one. Let's see, is half of B, so half of negative 12 squared, negative 6 squared is 36. Is that the C? Yes. Okay, so now that we've decided that they're all perfect square trinomials, we're actually going to factor the expression some more. So remember, we could use add multiply. That's what we learned when we factor trinomials with a that's equal to 1. So what are the factors of 1 that add to negative 2? And the answer is just x minus 1 and x minus 1. And the second problem, same thing. We're going to factor it using add multiply. So what numbers multiply to 25 that add to 10? And you should be saying 5 and 5. And then the last one, again, we want to add to negative 12 and multiply to 36. So that is x minus 6 and x minus 6. Okay. So now what we're going to do is start from scratch. If I don't give you the c value, can you tell me what it would be? So I want you to half the middle term, so half of b, square it. Half of negative 4 is negative 2. Negative 2 squared is 4. And then I also want you to rewrite the trinomial as a binomial squared. So let's see if we can notice a pattern. And let's go back up here to these actually before we do that. Would you agree that I could write this as x minus 1 squared? And this as, oh, this should have been a plus, sorry, x plus 5 squared. And this one as x minus 6 squared. So say you don't want to have to go through all the motions of add, multiply, add, multiply. There's actually a pattern. And the pattern is this part. After you have it, right before you square it, so after you have it, right before you square it, that will always give you the factor. Here, and here, and here. So you actually don't have to use add multiply at all, as long as you remember that little trick that after you have it, that middle piece is 5, that's what you would square as the binomial. So if I'm looking here, after I have negative 4, I get negative 2. So my factor is just x minus 2 squared. Okay? So let's move on to the next one. Let's find c first. Half of 6 squared. So 3 squared is 9. Now, we're going to factor this. This is going to be x plus 3 squared. Because of this part right here, it's a positive 3, and that's it. All right, in the last one, we're going to take half of 10. And we're going to square it. So that is c. And again, if I want to factor it, I'll just take the part that has been halved, and that is my factor. Okay, now let's put all this information to use to actually solve some problems. All right, let's move on to the back. All right, so the first question, or the examples, are saying solve each expression by completing the square and then describe the roots. So the steps that I have up here this is one way to do it, but I'm actually going to modify these steps. So the first step that I want to do is not set the equation equal to 0, but set the equation equal to the constant. And the constant is just the number. So let's do that first. So in problem number 1, I have categorized this where it says a is equal to 1. All that means is this leading coefficient, the ax squared, is 1. So we're going to do step 1. Set the equation equal to the constant. So I'm going to subtract the 24 on both sides. So we have x squared minus 8x equals negative 24. And then step 2 says the x squared must have a coefficient of 1. Take out the leading coefficient if we need to, which we don't. Now, step 3 says take half of b and square it. We need to create that perfect square trinomial that we talked about before. So my b value is -8. So half of b divided by 2 squared. So the b value is -8. -8 divided by 2 squared. -8 divided by 2 is -4. I square that and I get 16. So this is the value that would make this trinomial be a perfect square. So we can go ahead and say x squared minus 8x, leave some space, equals -24. So what we're going to do is we're going to add that value, so plus 16, and we're going to add it to the other side as well to make it even. Whatever I do to one side, I have to do to the other. So just to modify these steps up here, I wrote here, I said, then add and subtract that number to the left side of the equation. That's one way to do it. But what we're going to do instead is we're going to add that number to both sides of the equation, which we did, right? We added it here, 16 and 16. We did that so that we can create our perfect square trinomial. And then all we're going to do is factor and solve. So we have our perfect square trinomial, which we know from the previous page can be broken down in two of the same things being multiplied together. So you could do add multiply real quick, or you could just know the trick that we talked about before, that it's x minus 4 and x minus 4, and we could write that as x minus 4 squared. So basically it's half of this -8, and you can actually get that from here. So you see how we did -8 divided by 2? We got -4. That's that half value. So that half value squared is what it's going to turn into when we factor it. So we just need the x in front. So x minus 4 squared. And then we're going to add -24 and 16 together. That will give me -8. And then we're going to solve. So in order to get rid of the square, we have to square root both sides. And when we square, the square and the square root cancel each other out. And we're left with x minus 4 equals, and then we have to break down the square root of -8. So remember, we could take the I and bring it outside. So this is I rad 8. And to get x by itself, we can add 4. So we have x equals 4. Remember that when we have a square root, it's plus or minus. So 4 plus or minus I rad 8. Now technically, we have to break down this radical 8 a little bit more. And we know that the square root of 8 can break down into 4 and 2, which can break down into 2 rad 2. So my final answer is just going to be this I radical 8. We need to replace it with this 2 radical 2. So if we had to put the I in front, like we have here, right? It's I radical 8. We can bring down that I, and really this is 2I radical 2. That's what this simplification would be. So I'm going to replace that in here, my final answer. So we get x equals 4 plus or minus 2I radical 2. And that is my final answer. And then when I say describe the roots, describing the roots just means that the roots are imaginary. And the roots are imaginary because we have an I in our answer. All right, let's do a harder example where we have an odd b value. So the same kind of situation, my a value is still 1. So our first step is going to be to set it equal to the constant. So step 1, set equal to the number. So we're actually going to move this 10 to the right side. So we have x squared equals 3x minus 10. We actually have to move this 3x to the left side. So we have x squared minus 3x and then equals -10. So step 1 is complete. we set it equal to the constant. Everything else is on this side. Step 2 is going to be to create that perfect square trinomial. So perfect square trinomial. And the way that we do that is by taking b over 2 squared. So I always like to do that on the other side here. So b over 2, this whole thing squared. Now my b value here is -3. And when I halve that, it's actually not going to go in evenly, right? 3 and 2 don't divide into a whole number. So what we do when we have this, we're actually just going to square this whole thing. So we basically square the top and square the bottom. So what it means is you're technically doing -3 squared and 2 squared. That's how I square a fraction. So -3 squared is 9 and 2 squared is 4. So 9/4. And that's the number that we're going to add to both sides of the equation just like we did before. So we have x squared minus 3x, leave some space, and then -10, leave some space. So we're going to add that 9/4 to this side, and we're going to add the 9/4 to this side. And what we can do is simplify a little. So go ahead, pause the video, and type this into the calculator, and then hit resume when you're ready for the answer. All right, so you should have gotten -7.75, which I need it to be a fraction. So this should be -31/4. And now we want to write this perfect square trinomial as something squared. So we know we need the x in there, and this half spot will always tell you what goes there. Remember, that's what we did in the other problem. Just because we're not dividing it doesn't mean we can't use this. So we're actually going to use this as x minus 3/2. And then just like we did before, the last step is going to be to solve. So we're going to take the square root of both sides. The square and the square root cancel each other out. So we have x minus 3/2 equals plus or minus, don't forget to drop out the I, and then radical 31/4. So just like we did here, where I square the top, square the bottom, when you have a radical like this, you could square root the top and square root the bottom. So if I were to simplify this, I'll follow it up here, we have x minus 3/2 equals plus or minus I rad 31 over the square root of 4 is just 2. So what I did here was I kept the square root of 31 on the top, and then I took the square root of 4, which is 2. So then my last step is going to be to get x by itself, so I could add 3/2 to both sides. So we have x equals 3/2 plus or minus I rad 31/2. And then that would be my final answer. And these roots would also be imaginary. And imaginary because we have i's in our answers. All right, that's it for today. So I'd like you to jot down any questions that you have and then ask them in class tomorrow. All right, have a good night.